Let's talk about cache, or actually caching. I was hoping that would get people's attention, but that's okay. Caching, which, this is one of these pervasive ideas in computer science. Sort of any level of a system that you study, probably there's a notion of caching something. And really, it all boils down to one concept. It's about avoiding needless repetition of work that you have already done. So what are the manifestations of this in software as a service? Well, because we have a database-backed app, one kind of caching might be if you do some query and the answer to the query hasn't changed, can you just have a cached copy of the answer and avoid bothering the database later? Remember that the database is kind of the piece that is most difficult to scale in SaaS. So anything that we can do to sort of be nice to it is probably going to be well rewarded. If you have spent time rendering part of a page, right? We saw when we talked about partials that one way to build up a page is to have like these little independent pieces of it, and you sort of assemble the pieces at the end. There's actually two kinds of work involved when you're rendering each of those little pieces. Usually each piece is probably based on some model data. So in order to build that little piece, you had to do a database query. And there's some code that has to run to actually convert your ERB into HTML that can be packaged and put together. So that work is also something whose results could be cached. This also means, though, that you need to be able to detect when your cached copy of something is no longer valid. In other words, the conditions under which it was computed no longer hold, and so it is no longer an accurate representation of reality. There is a lot of different ways that you can cache in software as a service, and specifically in Rails. The code for doing it can get a little bit subtle. So my goal is not for you to learn what the APIs are. My goal is that you understand what are the sort of units of cacheability. How do you think about caching for software as a service? Because if you understand that, and if you understand how you think about expiration, how you think about timeouts, how you think about, given this thing that I want to cache, what are the conditions under which it was computed? And how would I detect if those conditions change so that I have to now invalidate that cached copy? If you understand these concepts, it's easy to sort of look up how they actually map to code. Like, what are the actual function names that you have to use to do it? So don't worry about code examples. I will show only what's needed to get the point across. But I really want you to understand the concepts of where and how are the opportunities for caching in software as a service, and how do you do invalidation. And here I will pause and I will paraphrase a quote by Phil Carlton, who many years ago was the technical lead for developing the X window system. If you are running Linux on your laptop and you are seeing graphics instead of text, you are using the X window system. You might think you're using GNOME or something like that, but all of those things, the underlying graphic system that it's based on is called X. And that was developed between MIT and Digital Equipment Corporation in the 1980s. This is a paraphrase of his quote. He actually said there's only two hard things in computer science: cache invalidation and naming things. My version is that there are two hard things in computer science: cache invalidation, naming things, and off by one bugs. But take that with a grain of salt. So where do you cache things in software as a service? Or what is the cache flow? Come on, that was good. All right, whatever. If we actually start at the back, start at the database, as I said, if there's a query that whose results have not changed, so for example, you're doing a join across multiple tables because you're traversing an association, as long as the underlying tables haven't changed, you can cache the result of doing that. And most databases already do this. So you don't generally have to explicitly deal with the database cache yourself. One thing we'll talk about is when we're putting views together, we can cache different pieces of the view. And as I said, a view really has two components. There's the HTML.erb that's used to render it, and probably there's one or more models whose data is being used to populate it. So if you can keep track of when those things expire, you can cache a fragment of a view. And now when it's time to put the view together, you don't have to rerun all that code, and you can probably avoid hitting the database again. At an even higher level, the result of running a controller action is usually a page of HTML. It's been assembled out of fragments, but if the exact same URI would give you the exact same page, you can actually cache the entire thing. And if that page is not protected by something like a before action, for example, maybe only certain users can see the page, or maybe the page is tied to a particular user because when they log in, that's the collection they see. But if the page is really and completely, totally generic, then you can just cache the whole page and not even ask Rails about it. Just grab the exact page image from somewhere that your app server doesn't know about. So in that case, not only are you reducing work for the database, you're reducing work for the app server. That's more users who can use the app. And then finally, when the user finally gets the content in their browser, the browser does a bunch of caching of its own. And so there are rules about there are cache headers that come from the server, giving hints to the browser about how long it is okay to cache an HTML page or to cache specific assets associated with it. So for example, maybe the page text is not cacheable or not for very long, but if the page has embedded images or if the page loads style sheets or loads images, those things can often be cached because they don't change very often. And so the user's browser cache is usually responsible for doing that. So basically, there's no tier of software as a service that doesn't have the opportunity in some way to use a cache to avoid repeating whatever work was done at that tier. So now let's go back in the other direction and look at these in a little more detail. Like I said, the big win is if you can cache the entire page. So in Rails, a page is more or less what comes out of a controller action, right? The controller action is going to render a view, and however that view is put together, the result is a blob of HTML. So if the entire action can be cached, then you can actually offload that to the web server, and requests that will hit the cache page, Rails will never even see those. Now, they'll appear in your logs, so you'll know that somebody tried to access the page from the web server's point of view, but your controller will never have gotten those repeated requests. Oh, and by the way, I should point out, there's both page caching and action caching. In both cases, the unit of the thing being cached is the whole page, but the difference is action caching actually runs the controller's filters first. So again, if you have filters like the user has to be logged in, or it identifies which user it is because the view of the page depends on that particular user. Obviously, in order to do that, you do have to at least touch the Rails stack. So action caching will run the controller filters, but if the filter runs successfully and the page is cacheable, you get to bypass the entire view rendering step. Actual page caching doesn't even do that. The page caching does not touch the controller at all. A big caveat about these is that page caching is based on the URL, not including the query string parameters, right? So if you remember, in our simple Rotten Potatoes app, we were passing parameters as part of the URL, and that would result in filtering what the page view was, right? Certain movies would or would not appear in the view depending on the value in the query string. So that's tricky because the page caching that's built into Rails only looks at the path portion of the URI. It doesn't look at the query string. So two URIs that differ only by their query string look like they would map to the same page. And very often that's not what you want, right? Like in our Rotten Potatoes app, the way that we implemented it, it wouldn't work. So for example, if we were filtering movies by rating and the rating was a parameter in the query string, page caching would break this because page caching would not include these parameters, which actually do affect how the page turns out. But if we had chosen a scheme where the thing that we're filtering on becomes part of the URI, this would work with page caching because now the entire URI matches the name of the cached object. So the pitfall here is be careful of mixing code paths in the same action that have a filter or not a filter. For example, don't do this. Don't declare that you're caching the entire page resulting from the index action, but inside the index action, you're basically doing a check that gives you two different page results depending on whether, let's say, the user is logged in or not. A better way to do it is you have a before action that checks if the user is logged in, and now you run an action cache on, you have a public version of the index and you have a private version for people who are logged in. Now, because the before action will run as part of the action caching step, this will actually do the right thing, right? So now there'll be sort of different versions of that front page, but the correct version will actually be selected. Even with this simple kind of caching, we actually loaded up Rotten Potatoes with about 1,000 movies, and then we added about 100 reviews per movie. And we basically looked in the Heroku logs to see how long the response time was when we were trying to create and read all these movies back. So the bottom is basically with no caching, the app as you've currently implemented it in most of the CHIPS assignments. And it's a little bit over about 449 milliseconds to essentially start reading all the movies along with their reviews. And you can see that with page and action caching, the bottom line is you can serve 8 to 20 times as many users with the same amount of hardware. So if you can take advantage of caching, the wins can actually be pretty big, right? It is sort of multiple integer factors is typical. And again, if your goal is to stay within the platform as a service tier rather than building all that stuff yourself, anything we can do to sort of squeeze more value out of the hardware is worth doing.